Hi, welcome to Module 4. This is actually Chapter 5 in our text. And this set of videos will be this PowerPoint talking about terms, and then another set of PowerPoint videos, or not PowerPoint videos, but open screen videos where I'll be drawing, and I'll actually go through these terms and what they mean mathematically, working with the science of weather. So here we go. First off, with just hydraulic cycle. The Earth is made up of a hydraulic cycle. The action of water changing phase and being moved around the Earth's surface in various phases is one of the ways that we displace heat from places of energy surplus to energy deficit. So it's the one of ways that I gain energy from its concentrated regions in the equatorials and move them out towards the poles. This is the easy form of the cycle, our little water cycle, and you can think of it going all the way back to elementary school when we talked about things like condensation, evaporation, right, precipitation. One of the simpler things that I'd like to remind you is that the act of evaporation is the act of heat energy, so thermal energy, acting on water droplets. So they're changing phase so that they are going from their solids or their liquid phases into their gas phases. From there, they will cool down. So the act of what's happening is another thermal action. This time, the heat is being removed from them, and they are condensing. So condensation is the action of cold, right, on it, and it is condensing on itself. And it's going back into the phase, which is either the phase of solid or liquid, right? And then finally, precipitation, which is the act of gravity, pulling it back down towards the Earth's surface. And so that really simple key is something that I would like you to put to memory, because it's something that you have to keep in mind in all of our actions. So as we begin to talk about more complicated forms of energy, we have to remember that evaporation is the act of heat, condensation is the action of cold, and precipitation is the action of gravity. I know it sounds really oversimplified, but it's important to throw it in our mind that way. As I said, we have these terminologies, and so right here we have the term of evaporation, term of condensation, and the final one is the action of saturation. There is a level with which I can saturate the air, or an amount of water that I can have in my air, and that depends on the temperature of the air, because the air molecules in cold air are condensed on themselves, right? They're really close together. And the action of warmer air, they're vibrating and they are moving farther and faster. So they're farther apart, or they're pulled away from each other. And so that is my saturation, or my ability to fit more water in warmer air. So the warmer the air temperature, the more water I can put in that air before it meets its saturation limits. So just evaporation, condensation, we more or less know what this is, but in this picture, it just shows, this one has no action of evaporation or condensation. This one has some evaporation and condensation. And at saturation, evaporation and condensation are exactly balanced. They are at 50-50, which means every time a water droplet evaporates, another water droplet condenses. So another water droplet goes back into a solid or liquid form. That does not mean gravity is pulling it down. Think of a cloud. Why do I go from not being able to see the moisture in the atmosphere until I hit a certain limit in the sky? And that's because at that spot, I'm meeting my saturation, right? I'm meeting my absolute saturation. My concentration of saturation is being met. So water is coming out of suspension, going back into liquid or solid particles, and all of a sudden I can see them, right? Because they're liquids and solids again. They're no longer gases. So it all makes sense. It all holds true. And it's something that you can continue to work with. And we will when we talk about the adiabatic process. So here we go. Evaporation, condensation. Two other terms to keep in mind is deposition, which is my gas phase going to my snow phase, right? And sublimation, which is my water vapor, my solid phase, going into my water vapor. So one direction versus the other direction. So that's when I'm skipping my staging. Another term is humidity. The general word humidity just means water in gas form in the atmosphere. All humidity means, water in gas form in the atmosphere. Vapor pressure is the amount of pressure that water is exuding down on the surface or down on yourself. Saturation vapor pressure is the amount of material or water that I can have in my atmosphere given at certain levels of gravity pulling it down to the surface of the earth. Saturation vapor pressure changes based on temperature. And this line right here is my maximum saturation vapor pressure. What that means is that everything on this line itself, that pink line down here, is 50-50, where evaporation is equal to condensation. Everything above this line has evaporation being greater than condensation, or condensation being greater than evaporation. So that means that everything that would be evaporated out is coming out of suspension immediately. So this is 100% saturation right here. This down here is greater than 100% saturation. Everything above this line is greater than 100% saturation. Think of fog, right? If there's a fog and I'm walking through a fog, I've exceeded my saturation vapor pressure line right here. And I am now at a point where all water that is being evaporated is immediately coming out of suspension and turning back into a liquid or a solid. So it's becoming the other two phases in my set, no longer gas. Everything below this point, everything below this line has evaporation being greater than condensation. So there's a lot of evaporation occurring down here, and there's still room for more evaporation. I can put more water molecules in its gas form into my atmosphere if I'm below this line. One of the key things about this line is that it's based on temperature and the saturation specific humidity in grams per kilogram. So if I told you that the temperature today is 30 degrees Celsius, which is really warm, it's 90, and the water in the atmosphere is 15 grams per kilogram, I can line these two lines up. Here's 30, here's 15, and I can line up, boom, and boom, and I get my dot right here, and I can tell you that it won't be foggy right now, and that there will be more evaporation, and there will not be a lot of condensation. Right? So it's going to be hot, it's going to be fairly humid, but there's still room for more humidity or more moisture to grow in the atmosphere. On the other hand, if I told you it was 20 degrees Celsius, so let's say it gets later in the day, right? And the temperature starts to cool off, and it cools off to 20 degrees Celsius, and I still have 15 grams per kilogram. I line up my line, and I get myself right on this line right here, and all of a sudden I've met my saturation. I'm at 100% saturation. So what I can say is clouds might form now, and we might see some precipitation if those droplets get big enough for gravity to drag them back down to the surface of the earth. So this is how I use that line, and I will show you on the little iPad screen. I'll put out the whiteboard screen, and you'll see me draw all this out and play with this curve a little bit more because I'd like you to see how it works. You're going to need to be able to use it, right? Another term, absolute humidity. Absolute humidity is another way of saying the exact amount of water present. So if I take my measurement of atmosphere and I take a little meter cube, right? So I take a little 1 by 1 by 1 meter cube, and I measure out how many pounds of water or how much weight of water in grams that I have in my cube. I get a certain amount of water. That's my absolute humidity. It's the exact number of the amount of water present. Another term, specific humidity. That is based on the mass of the water vapor at the given air. Specific humidity is another way of saying exactly what's present, right? It's exactly the amount of water present at that current time. And saturation specific humidity is that 100% vapor pressure. It's exactly how much water can fit at this given temperature. It's the maximum amount of water I can have. Anything over this number, another droplet of water is immediately coming out of suspension and going to solid and liquid, so it's staying right around 100%. So on those terms, I will pick up with more terms in a part 2.